Atmospheric pressure. What is atmospheric pressure? It's amazing how many people don't know what atmospheric pressure is. Drives me crazy. You're an HVAC tech, you better know what atmospheric pressure is. Gotta. Because you live in it. This is our environment. Atmospheric pressure. This is what's around your body every day, all day long. If you didn't have atmospheric pressure, you would be dead. Pretty much. Gotta have it. So, pressure exerted on the surface of the Earth by a weight of a column of atmospheric air extending upwards from the surface to the top of the exosphere, try that one, which happens to be 6,200 miles above sea level. That's a long ways up there. But in that exosphere, all the way down to the surface of the planet, and you can see the different spheres. You got the thermosphere and the mesosphere and the stratosphere and the troposphere. You got all those different spheres of atmosphere. Exosphere is the top level that still has something in it. And when I say something, I'm talking about atmospheric, like oxygen, nitrogen. Those type of gases are still existing there, but there are not much of them. But they have to be considered in the big scheme of things. At sea level, standard air has a weight of 0.076 pounds per cubic foot. So I got a cubic foot of air like that. That's 0.076 pounds. At sea level, don't forget that. And that's something, the weight of air, the volume of air, all that stuff is something we'll cover in the air properties and measurement course. But this is, like I said, this is an intro to get your head going the right direction. So we'll get to that later. Air does have a weight, absolutely has a weight. It's a substance. H2O is water, that's in the air usually. You got oxygen, you got nitrogen. All those things, oh, and then you have rare gases. But all those things add up to something. Okay? They are something, and they have weight, all right? And they take up space. So, it has a weight. If you have a 1-inch square column of air that extends up 6,200 miles to the top of the exosphere atmosphere, it will weigh 14.7 pounds. So, 1 square inch surface at sea level on the planet Earth, if you could weigh it, would be 14.7 pounds. And there are ways to weigh it, by the way. But we don't measure atmospheric pressure in pounds, we measure it in inches of mercury, or abbreviated as inch sign Hg. Standard atmospheric air at sea level is measured at 59 degrees Fahrenheit. It's 14.7 psia, pounds per square inch absolute, and 29.92 inches of mercury. Atmospheric pressure is a result of Earth's gravitational pull on the air above the surface. Atmospheric air has weight, takes up space, and gravity affects it just like it makes you weigh in pounds. Why do I weigh anything? It's because I have gravity, the force of gravity pulling me down to the surface. Okay? Recognize, and this should be obvious at this point, recognize as you get higher above sea level that there is less air above you. You know, so you think of yourself in this atmospheric levels, and as you get higher up in these levels, there's less air above you. So that means a column of air has less weight. Measured pressure reduces, you go up. This concept is an important one to understand because it has implications to several HVAC issues. One typical issue is, as I mentioned earlier, is the combustion process. There is a difference in a combustion process at sea level versus, for instance, Colorado, like Denver, the mile-high city. There's a difference in that combustion process because you're higher up in the atmosphere. Okay? And I'll give you some examples here. Standard atmospheric pressure at sea level is 29.92 inches or 14.7 psia or 0 psig. Standard atmospheric pressure at Denver, Colorado at 5,278 feet above sea level, that's what ASL stands for, above sea level, is 24.82 inches of mercury, 12.2 psia, which is 2.5 psi less than sea level. So you can see as you go up, and now we're about a mile or so above sea level in Denver, Colorado, there is less of a column of air above you. You're still on the surface, but now it's less weight. And then if you go to the very top of the world, which would be the top of Mount Everest at 29,035 feet above sea level, the pressure is 9.92 inches of mercury, so it's really, really reduced. We lost basically 20 inches of mercury on that measurement. It's 4.89 psia, and it is 9.81 psi less than at sea level. So it should be logical as you go higher up in the atmosphere, but still on the surface of the planet, like Mount Everest, you have less pressure upon you. Higher equals less pressure from the atmosphere. Okay. Did you get it? I hope so. Atmospheric pressure. We're still on that topic. In the US, atmospheric pressure is measured in inches of mercury. Go figure, you probably should have that by now. It may be difficult to understand why use mercury. Well, I'll tell you why we use mercury. It's a liquid metal, okay? Very heavy, but a liquid easy to use to measure atmospheric pressure in a compact space. And that's the big deal. Having an instrument that is able to measure pressure that's not overbearingly large. By using liquid, any changes in pressure are observable and are known immediately. Water can also be used to measure atmospheric pressure, but the limitation to a water barometer is size. A water barometer would have to be 34 feet tall to do the job. And there are water barometers out there. People sort of build them as a hobby. But a water barometer works, but it's 34 feet tall. Try packing that around in your pocket. It's a very inconvenient size. Mercury is much heavier, so it's able to be done in a height of 31, 32 inches high. So if you had an actual mercury barometer, which there are out there, it would only have to be about less than 3 feet tall. A significant difference between 34 feet. So we animated a mercury barometer here to better understand how it works. One important concept to understand is the seal tube that you'll see in this video is in a perfect vacuum, which means a total absence of pressure from any source, and is immersed in an open pool of mercury. This allows the mercury to rise in the tube under the influence of atmospheric pressure as it is applied to the exposed surface of the mercury.